Simi Oluwatomi is going to be talking on unraveling software architecture for the web. Please, let's give a round of applause as we welcome Simi to the stage. Simi Oluwatomi is a back-end developer with experience in the fintech and healthcare industry, with a proven track record of designing and implementing scalable and secure software solutions that enable organizations improve their operations and enhance their customer experience. Thank you. Welcome, Simi.
Hello, everyone. Okay. Good afternoon, everyone. I hope we are all having a good time. So, my my talk is titled "Unraveling Software Architecture for the Web," um, and I'll get quick into it like as quickly as possible. But before I do that, I want to say thank you to the organizers. Obviously, you can submit a talk and then they will reject you, and sometimes you don't even get a rejection, they just ghost, but thank you to the organizers for putting this together. So the agenda is very straightforward. um, what is software architecture, why is it necessary, some principles that you need to consider when architecting for the web, and then some fundamental web architecture components and then we are going to look at architectural styles for the web, and hopefully we can get to QA, right? So who am I? I'm an experienced they say I'm an experienced backend software developer. I'm not sure if that is me, but I like teaching, I like public speaking, and doing technical workshops. I also love football, soccer. Yeah, football. Yeah, so God can bless. So some US guys may be watching this and they will think I'm talking about American football. No, Messi is bigger than all American football stars, please. I also love chess, table tennis, and photography. Yeah, let them hear and they can drag me on Twitter. Anyway, what is software architecture? So as developers, so the reason for this talk is that as developers, we get a brief for something, and we just open our code editor or IDE, and we start defining variables and all of that. Now, when I started working in the corporate environment, I realized that I needed to work with business analysts, I needed to work with IT departments, I needed to work with product departments and all of that. And we would go into meetings, like brainstorming sessions, and they would be talking, and I thought that I was the smartest person in the room, but they are talking and I'm looking at their mouths and writing in my jotter because they are talking about things I don't understand, right? So that took me down the journey of what it really, really means for a developer to work in a structured environment for like medium to large scale enterprises. And I realized that for most of the people that work in that kind of environment, the first thing you learn early is software architecture. Now, software architecture is the overall organization of any software system, including the components. That's number one. Number two, the relationship between the components. And then number three, how the components behave. So you could have like two or three components, and there is a path for each of these components to talk to each other. So what software architects generally do is to create a system, like a diagram or something, and then you can view the system from the top down to the details. Now, This second slide shows a maze, and the reason I chose that is because as software developers, it's very easy to get stuck in the maze. Like you are defining your database migrations, you are declaring variables and writing classes and all of that, but you don't know the big picture. And the only way you can know the big picture is to look at the maze from the top. Um, the analogy comes from Maze Runner. I don't know how many of us have seen that movie where people are put in a maze and they have to figure out the way out, right? And then at the end of the movie, they show what the maze looks like from above, and you realize that it's like bigger than you ever think, right? So many times in medium to large scale enterprises, your software is just one tiny bit of something that you are working on and missed the whole maze in that organization. So why is software architecture important? Number one is that it ensures that software aligns with business needs, right? You may be thinking, in the organization I work for, like the software is the business, right? But in many organizations, the software is not the business. The business, most times, it's an Excel spreadsheet, right? And your software is many times a way to model that same spreadsheet, right? So you are wondering why an organization has just one single Excel spreadsheet and it's 200 megabytes in size, right? I have seen organizations like that where you want to open an Excel spreadsheet and you have to go grab coffee because by the time you grab coffee and you come back, the spreadsheet is still loading up. So you realize that your software is not the business. That spreadsheet, if it gets lost, then all of you will be out of a job, right? Number two is that it eases communication among business and technical people. And as programmers, we like to speak tech speak, right? You talk about classes, you talk about models, you talk about migrations. Meanwhile, the accountant is telling you to simply debit an account and credit another account, right? So software architecture places you guys on the same wavelength. They talk in a language that you can understand, and you talk back to them in a language that they also can understand. And the truth of the matter is that in most traditional organizations, engineering is just one department, right? In the first presentation by McNeil, he was talking about IT departments, and you are wondering what's the difference between engineering and IT, right? So IT, the day you resume, IT is the one that gives you your computer, not engineering. Engineering is strictly software development. Number three is that software architecture provides a roadmap, right? For freelancers among us, maybe you are bidding for a job on Upwork and all of that. One of the biggest challenges is that you have to estimate the cost of that project before you have seen anything, right? And many times, when the client eventually comes and talks about their software in their first session to you, you go, oh, I'm definitely being underpaid, right? Because the roadmap is bigger than what you charged for. Number three, the next is that the roadmap now reveals the cost of that software to the business, right? Because to start things, organizations think about things in cost-benefit ratios, right? So if the cost to digitize an Excel spreadsheet is the salaries of 10 developers, then the organization does not have any incentive to turn that spreadsheet into a software, right? So a roadmap ensures that, okay, the organization knows the cost to build this thing, number one, and then the cost to maintain it, that's number two. Because many times you go into organizations and they don't have a software development team. Everything is done what? Is contracted out to agencies, right? And when you hear the amount those agencies charge, you'll be like, I can build this thing. Why are they charging 10 million for a landing page, right? It doesn't make sense to you because the organization simply does not want the cost of maintaining that particular project. And then the last thing is that software architecture provides training materials for onboarding. So you get into a new organization, you are issued your laptop, and then your onboarding begins. I don't know how many of us have done onboarding before. And then you are like, what am I building? You have installed Git, you have installed your VS Code, you have installed your IDE. The next thing is, what am I building? But to build anything, you have to understand the existing systems. So in those cases, you now hear that, oh, there is something that is still running on Node version 5 that is on a server that the person that has access to it is on leave. I don't know if that has ever happened to you, right? And the reason is because why? There was no architecture done for that particular piece of software. Because if it was available, that person does not need to come back from leave before you can be onboarded to that project. So the next we are going to look at are the principles of software architecture. Now, as someone that has worked in highly regulated businesses or industries, healthcare and fintech, the first thing I think about is what? Security. If your financial application or your healthcare application is not secure, everything that you have after that, permits me to say, is crap. Right? So for me as an individual and people working in the kind of industries I have worked in, security is the first principle. So it is not, security is not that thing that we do after we have finished building the software. It is that thing that you do even before you write a line of code, right? Number 2 is reliability. Now, when we think about software, the first thing is that the software must do what it says it does, right? So I'm using a financial application. I want to send money from one account to the other, right? The first step on reliability is that that software does what it says it is going to do. The remaining steps on that ladder is that it does it in a repeatable fashion all of the time. Right? So if your software does not do that thing it says it's going to do in the first instance, then you have nothing about reliability. Right? So the next is maintainability. So one of the things that we are famous for doing in our industry is that we hop from one job to another every 6 months. Right? Am I lying? In fact, some of us receive offer letters. We resume on Monday and we send our resignation letters on when? On Friday, right? And one of the things that does for us is that we don't work on projects long term. So you want to move fast and break things, and then you move so fast that the person that comes after you is always swearing for you. I'm serious. Like, the person opens the code base and is like, who wrote this? God help you, you used your real name in the Git commit message. The person finds you on LinkedIn, and then what they do is to say, guy, God punish you. Right? And then the last thing is performance. Right? In software architecture, you always have to think about how fast something is. Because high performance systems are highly usable systems. Right? Imagine clicking a button on GTB's mobile app. You don't have a response, and the thing just continues to spin. What do? You just close it, right? So you want software that is fast, that is efficient, and that is usable for your users. And that's what performance does. Now, I have a quote here that says, scaling becomes a walk in the park when you have software that is what? Secure, reliable, maintainable, and performant. And the issue I have seen is that many times we try to scale software when one or more of these things are not present. So what happens is that you are scaling the wrong thing. And for the lifetime of that project, you have to fix those issues that you had in the beginning. Right? So your software is not secure. You are always having data breaches. the next thing you do is say, you know what, let us export our authentication system to who? Towards zero, right? Now, by doing that, you have added another cost to that software just because you want to do what? You want to be secure, right? If your application is not performant, your architecture is going to tell in the bills that you receive at the end of the month. I once wrote something that was hogging memory every day, right? We had to shut down the server after every 45 minutes because it will just go from 0 to 100% and users will just what? Hang. The funny thing is that we had less than 1,000 users. So what was hanging the thing? It was my code. I wrote bullshit and we tried to scale it out, right? So what are the fundamental web architecture components? The first thing you have to know is the presentation component. Many times we think about the presentation layer as the client's browser. The presentation layer could be anything. Because as technology has advanced, we realize that you now have smart televisions. So the presentation layer could actually be your TV. Am I making sense? The presentation layer could be your watch. The presentation layer could be anything. It could be your microwave. It could be your refrigerator. So the presentation layer is not limited to a client's browser because browsers have now become portable. They can be exported from one place to another. Then the second component is where you have your business logic, right? Many times, depending on how you like building applications, you could say, let me do all my processing client side. That means on that TV app, or let me do it server side on my servers, right? But many times you realize that business logic is needed in both places. So for instance, someone who is not logged into your fintech application should never be able to send money. Because who is sending money? So imagine that, yeah, that's the truth. Now imagine that your backend obeys that principle, but because you have been told that business logic belongs in the back end, you now show the button to send money to everybody, even those that have not logged in. I mean, just think about it. So business logic could be where? It could be anywhere. It could be in your presentation layer or it could be in your server side. Now, the next thing I want to talk about is the data access component. And the funny thing is that this is also in both places. It could be client side, it could be server side. Now, one of the things that MVC frameworks and ORMs have done for us as developers is that they have combined the data access component and the database component into one. So, all over your server-side application, you have database code spread everywhere. But if you are a good backend developer, you would actually know, you would have seen people talk about repositories. So what do repositories do? They are simply the data access component. A repository's biggest selling point is not that you can wake up tomorrow and decide to change your database from MySQL to MongoDB. I have been working as a software developer since 2018. I have never seen that kind of migration. Why? It is hard. It's not something that you wake up one morning and say, I don't like my SQL. I like MongoDB. Let us change it. And in the next 1 hour, you are done. No. So that argument, for me, is we putting the cart before the horse. What your data access component allows you to do in your applications is to separate your database layer from your business logic. It is that separation of concerns that gives you peace at night. I'm serious. Now, the last layer is the database component. Now, when we talk about database components, stop thinking in terms of MySQL and MongoDB. Extend it to an Excel spreadsheet. Because I've actually seen applications that their database was an Excel spreadsheet. I have also seen that applications that their database is a Microsoft Access document. Some could be a text file. So, database is not MySQL. It is not Postgres. It is not just MongoDB. It is anything that can store information and that can store it for a long time. For people in the PHP community, we will notice that SQLite is making a comeback. Am I speaking? Why? Because people are realizing I can just create a .sql file and write to it. Now, let us talk about the common architectural styles for the web. I know you have been expecting to see something like MVC. Who was expecting to see it? MVC. But it's not there. Why? Any of this could be MVC. So let us talk about, we are going to take them one after the other. And the reason is because many times we start from, many times we start from microservices and we start from serverless. I am not saying they are bad, but as a developer, you should know the justification and the trade-offs between both. So quickly, the monolith is a single unified code base for everything. And they told us that it doesn't scale. How many of us have heard that? Monoliths don't scale. They lied. Shopify was a monolith for a very long time. And it was vomiting money. Like life-changing money. Money that if they give you, you will look at Burna Boy and ask him, who are you? The next step is the modular monolith. And the reason is because as your team grows, you find that managing a code base becomes difficult, right? And if you're a junior developer that was given a brand new project, you would have made rookie mistakes to couple everything together. So you had model view controllers, and then you handle your business domain inside your controllers. You didn't separate them. So developers looked at it and said, we can have a modular monolith in which every major component is a module on its own. So even for Sales.js, you could have a modular monolith. The problem with modular monoliths is that there is no agreed standard on how they should be done. So everybody does it the way they know how to do it. So if you join organization A and they are using Sales.js and they have a modular monolith, and you join organization B, you'll probably be working on two different code bases that have a lot of dissimilarities, right? But the problems inherent with monoliths are still in modular monoliths, because you can't decide and say, I want this one to be Java, this module to be Java, and then I want this one to be .NET, and that one to be Node.js. You can't scale each module independently, right? So, developers said, this is not good. Let us do something about it. And what did they do about it? No. What they did about it is what? Service-oriented architecture, not microservices. SOA is not microservices. So, let me give an example of a bank. A bank has a loans app, and then they have a savings app. But they realize that the loan app and the savings app both need an authentication system, right? So they take all their authentication, single sign-on, registration, password reset, and extract that into what? An independent service. So what you have in SOA is that you have services, but those services are bigger in scope than what you ever get in a microservice. So the difference between a service and a microservice is that one is more granular than the other, right? So now we have independent components that can be scaled independently, right? They can even be written in different languages, right? Now, there has to be something that couples all of those components together. And for SOA, that component is called an ESB, an Enterprise Service Bus. The problem that introduces is that ESB becomes the single point of failure of that system. If that bus fails, everything does what? It goes down. So the solution to that is what? Microservices. So you don't jump from a monolith and back to a microservices just because they told you microservices are the next big thing, right? Okay. So now what is the issue? Microservices now, you now have very granular services, right? And then each can be scaled independently just the way SOA works, right? But the problem is that developers are bad at building software. I'm serious. So what eventually happens is that we now build distributed monoliths instead of microservices. So you have a container of post service, and that post service is also tweeting. So the whole we now build microservices to defeat the purpose of the microservice in itself. So when people talk about AI taking our jobs, I don't agree with them. Because developers are bad at building software, meaning that we are also bad at building AI. So the softwares that AI produce will still do what? Will still be buggy. And when the software has a bug, an human being has to do what? An human being has to fix it. Are we still together? Now, we go from that to what? To serverless. And say, I hate servers. I don't like SSH. I don't like Telnet. Let my infrastructure service provider do what? Run everything. But the problem is that we are never going to be in an ideal world. So even when your infrastructure provider is running everything, you can be locked into that provider. So when GCP has an outage, just like the one they had 2 weeks ago, your software is toast. It's as simple as what? As that. And then the issue of cold starts never go away. Because the way serverless works is that it has to warm up, and then you call the functions, and then it shuts down. So when you want to call the function, if that warm-up is not done, it takes longer, right? And there's some programming languages like PHP that were designed to boot for a single request and also shut down. You have to know how those languages work before you can use them, what? In a serverless environment. So at the end of the day, serverless is good, but you have to be aware of the limitations that they all provide you. Right. Now, what are the best practices for web architecture? Very quickly. Number one is that you have to really, really understand what each of these bring to the table and know the problems associated with each of them. We do that a lot, but we don't do number two very well. We think we are all seniors. And the problem is this: you will always have a junior on your team. So when you are evaluating your team competency, know that one day you are going to hire someone that just finished a 3 weeks boot camp and is a junior developer. Number three is that you have to be as modular as possible. And what that means is that even in your microservice, you have to be strict about your interfaces. You have to be strict about their communication. What is supposed to be a method call should never become a network call. You have to be strict about how everything communicates between each other. Then the next is that you should actually be doing cloud computing in 2024. If you are doing shared hosting, my God will deliver you. Amen. Then the last one is actually the biggest part that I have issues with developers. You need to document everything. I am fortunate to work in an organization where at the end of the year, we stop, maybe by December, we don't release new features. And the only thing we do is to do what? Is to document. Because one day you are going to leave. If you go away with all the knowledge of that business, even though your contract is over, 6 months down the line, they are going to call you and ask you for an SSH key that was only ever on your computer. That has happened to me before, so I know about it. Now, questions. Okay, just 2 questions, please.
Good afternoon.
Good afternoon.
Thank you very much for your proper explanation on architecture. So, I work for Octosoft in
Okay.
Lagos. We're basically building EMRs for hospitals, and we also have the user end of things product. So now for our EMR, it's monolithic.
Okay.
I don't like monoliths, really, because it can get complex when we start to deal with. We use modular monolithic architecture,
Okay.
where we have each one of those services that we're offering, like the lab module, the pharmacy module, and all of that. So now, my question is, we're trying to move from a monolithic application to either a domain-driven design.
Sorry, please, can you be more audible, please? People
Okay.
online cannot hear you.
Sorry. So we're trying to see if we can move to a domain-driven design system architecture or a microservice architecture. So now, my question, right, is what would you advise in when we're comparing these two, cost out of it, cost is handled, but what would you advise we look out for if we're going to do the domain-driven? Because there would be some hospitals that want some services, and then there are those that don't want some, and you just want it to be business logic focused for each business. So what would you advise? Thank you.
Okay, thank you for that question. Domain-driven design is hard because you have to think about roots, aggregate roots, bounded context, value objects, and all those kinds of stuff, right? So what I would advise is that you build a dependency graph. See how your modules interact with other modules, and first try to build a strict interface between those interactions. So for instance, currently, something in the lab module may be able to call another thing in the, let's say give me an example of a module in the billing module directly, right? You can create clients whose dedicated purpose is to facilitate intermodular communication, such a way that when you decide to refactor to domain-driven design, your bounded contexts become very clear. Because even when you get to domain-driven design, you are going to have the questions of how to communicate between modules, right? So when you now have clean modules where you are sure that this is the dependency graph, this is the module that depends on this, refactoring to a microservice now becomes easier because you can see what each service should be doing. Do you get? So you don't want to just say, let me take out the lab module to a microservice. Because sometimes when you do that, the service may be too big. It may not be granular enough, right? So that's what I'm going to advise. First, refactor things out to make dependencies clear, and then start thinking about how to pull out things to their own services. Thank you very much.
Thank you very much, Mr. Simi Oluwatomi.